Yeah. Having a thing where people know it's been discussed, but it wasn't on the slides is the right middle ground. Yeah, no. I think
Okay, so we'll start very soon. So please take a seat here. Okay, let's get started here. Welcome to the Media over Quick Buff. I'm Magnus Westland. My co-chair here is Alan Frendell. So, this is today's agenda. We'll go over a few administrative things and lead up in, and then go into use case overviews, looking at a couple of different use cases, a little bit of the potential solution space for future work, but that's setting the stage for discussing what's possible, not solutions. Then we'll have the discussion and wrap up. So that's the plan for today. So the note well. So this is to remind you that it applies, and there's intellectual property, there's behavior codes, etc. So I have note takers, thanks to Jonathan Lennox and Stefan Wenger. If you want to help out in the hedge doc, please do. Reminder to everyone in the room, if you use the Meetecho Lite or Meetecho to join the queue. If you're using the full, remember to mute, etc. So, why are we here? We are here to discuss if there are media delivery challenges that we have common enough understanding of. So, do we understand what it is about, what the problems are, has issues or challenges that we have encountered, let's say, in trying to do things, not theoretical only. There are sufficient interest to solve, and they would benefit from standardization work and protocol definition. We believe that we can solve and is appropriate to solve here in IETF. We also want to see who's interested in contributing to working in this space. So this is a non-working group forming BOF. There are a couple of potential outcomes out of this BOF. One is that there's one or more problems, there's the sufficient support to be addressed and interest in. And then we go into some type of scoping of the work, figure out if there's an existing working group or you need to write a charter for it, and do the discussion around that. Such discussion will happen in that case on the mock BOF unless directed elsewhere. And then either recharter or have a working group forming BOF depending on how good the support agreement are around such a proposal. The other alternatives is that we actually need more description discussion before number one can happen. That's something say, okay, they are interested in doing something, but we are not really agreeing what it is. Or we could actually conclude there are no problem to solve at this moment. So that's kind of the scope setting, and let's go into the use case overview now with James. I must. Okay. Go ahead, James.
Excellent. Good morning, people. So in this bit of a presentation, I'm going to be covering a couple of different aspects of the use cases. Little disclaimer before I continue, this is the views of mostly myself and also of Spencer, and not really of a non-existent working group. We're also going to be talking about why quick, and describing sort of a high-level overview of some of these use cases and their applicability in sort of the TV domain. And I'm not going to be talking about requirements or solutions too much here. So, how did we get here? We got here because we've had an awful lot of discussions about this over a very long time. Some of the first bits of documents and discussions were happening 2017 and perhaps even earlier. We've also had the MOQ mailing list around for a while. We've had a few side meetings. There's also been, with asides from the use cases draft that myself and Spencer have been working on, there's also been many other drafts that have been published out there that have got some sort of an attempt to solve something that may fit into the use cases that we're going to be talking through today. And I'm not going to go through these, but there's a few here that just show sort of how long this timeline is progressing. We've sort of had these documents around for a couple of years now, and this isn't a complete list. There's RIPT, which is one other, and there's probably some more out there that we've completely missed. So perhaps the big question we've got to ask is, well, we have all these other protocols that can ship media. Why would we put all this effort into using Quick? Well, Quick, although it is quite general purpose, it gives a lot of useful functionality that have very useful applicability in the media domain. This is just a list of these, most notably the fact that a lot of deployments are going to be carrying it in order to do HTTP3 and other protocols as well. And so we can take advantage of these and sort of make use of them as best as we can. But what's more important, so let me talk about the use cases. So Spencer and I have spent an awful lot of time since the last side meeting better refining the ontology of these use cases. And this is not complete, but it is what we think enough to explain the scope and the area that we're working in. And I've put latency on the other axis, not because it is the most important thing, but more just to give some structure to this. There's certainly many other requirements, both functional and non, that we could do it. This is just one of them that clearly is very important for people. And just sort of working our way from top to bottom, we've got sort of what we call interactive media. So that could be things from like cloud-based gaming, remote desktoping operations. Both of those tend to be more of a one-to-one operation. And then we have video conferencing, which is either a one-to-one or a many-to-many. The live media use cases, which I'll be talking a bit more in depth here, but are not the only important ones. We sort of split them into three sort of groups. Live media ingest, which is where media is coming out of being sent on to somewhere. So an example would be an output from a camera into a transcoder or some other into the broadcast chain. Syndication is a little bit more complex, and this is sort of where it is being fanned out into distribution networks. So for example, when it comes out of the broadcast chain in television and needs to be sent on to cable TV providers or over satellite or terrestrial networks. And for live media streaming, this is playback. This is people consuming and watching live media. And lastly, and I'm not going to talk about this too much, is more of the on-demand media use cases where media is stored and also made available for playback. But for all intents and purposes, I'm not going to be dwelling too much on that one. So, just to set a bit of context here, this is a very oversimplified example of a television broadcast chain, end to end. And I've grayed out the bits that are perhaps not so pertinent for this discussion, but I think it's kind of interesting to talk about sort of the end to end or the glass to glass, call it what you will. And we start over on the left-hand side with sources, cameras, either inside of studio or remote, being fed into a central point, which is typically a master control room, and then managed and sent out into the distribution side of things, such as for transcoding and eventually delivery for the viewer in the IP domain. There is also, if we zoom in for a little bit, this lovely green box here of live streaming, and this is representative of use cases where we're talking about user-generated content. In these three sort of ingest arrows, as it were, the blue, the purple, and the green, they all are effectively ingest, but they do have some key differences in their requirements and how they work. The two most notable differences between them are around sort of throughput and resiliency requirements, and in some cases, bidirectionality. For outside broadcasts, for example, it may be required that you send audio and video both ways. Say a weather person in bad weather having an interview with a news presenter in the studio. They need that bidirectionality there. When we talk about syndication, this is, again, that fan out onto delivery networks. And there isn't, the key distinction here is that there isn't any further transcoding or splitting up of the video. There may be a transmuxing or a repackaging, but there's no further transformations to the video, no further editorialization. And then lastly, we got to the streaming, which should be fairly clear here, which is just people fetching the media and playing it out. That's pretty much about it. Are the use cases clear? Do people have questions? Or do you have other use cases that you don't think fit into this space?
Jake, go ahead.
Yeah, hello. Is that working? All right. Do you so when you're merging multiple media streams, does that go under the like which section would that go into? Or is that just a sort of independent question? Because you have to synchronize them, right?
So there's many points where you could have to merge. What context are you talking about specifically?
Well, I mean, I guess there's several that I think of as related. Those being things like multi-language channels for the audio streams, merging the video and the audio. You know, the sort of if you have any sort of user-driven switching of views, that is important to have synchronized on the viewer side. If you've got, and so I guess things like overlays also might be relevant here, although I'm not sure. Maybe that is a different section. So, but these are the kinds of things I was considering.
So they are an important concern, but I don't think that that's particularly orthogonal, because you have situations where at any point in this in the chain where there may be multiple forms of media. that need to be pushed through. So there are cameras out there that can do audio and video, and then there's others that are just video only because they're used in a studio where it's assumed that audio is supplied separately. And they're kind of like lanes in the highway, as it were, and sometimes they merge off, and sometimes they new lanes emerge, depending on where they are in the chain and what kind of things happening.
So part of the sort of solution space that this work would need to address is how to synchronize those properly, like RTP style with timestamps or whatever.
Yes, that may necessarily be an important requirement to solve.
Okay, just wanted to see if I understood where that fit. Thank you.
So Pete Resnick just left a comment in the chat. I'm happy to answer this. He says maybe the caffeine wore off, but is there something about the use cases that are different in streaming that is currently going on? I think the answer is no, there's nothing different here. We're just trying to be very clear about what is out there, what is the existing state of affairs in terms of where the applicability for this work might go.
Mo.
Mo Zanatti, in 2 more slide decks, there'll be more descriptions about the use cases, and I think it'll be clear what the real differences are between just today's traditional streaming and some of these new use cases that require maybe more advanced types of streaming, lower latency types of streaming, and maybe even more hybrid switching between extremely low latency streaming, almost like video conferencing type latencies, and traditional, distribution delivery. And for the comment about Jake's comment about, I would take it as almost like control protocols or I didn't think that the group was going to be looking at things like signaling and control protocols. Because you think about there's, at the bottom layer, there's media distribution and media transport. Then there'll also be, feedback and control protocols. And I didn't think that the people were in this group were going to be looking at the control protocols for things like user selection and things like that.
Thanks. Spencer? Spencer Dawkins. I just wanted to add, the draft that James and I worked on has a section trying to explain at a high level what the difference between interactive and live and not live, I don't remember what we called it, media, basically how we were fitting things into those different sections. And I should also mention that the slides that James is presenting have links to the different sections in that draft. So if you're trying to figure out things, if you click, if you have a copy of the slides and click on them, that would take you to the right place in the draft. Thanks.
Okay. Let's go to the next part presentation now. So Ying, I will put up the slides. If you don't want to draw. Let's see. Yeah, we have it. You can go ahead when you see the slides.
Do I control the slide or not?
I can. Now you should be able.
Okay, thanks. Hi, everyone. My name is Ying. I'm a software engineer working on YouTube's live streaming infrastructure. So today I want to talk about the challenges we see in terms of live media ingest protocols based on our experience. So first, to borrow James' diagram on the live media broadcast chain here, I just want to highlight the focus of the talk is on the live ingestion part of the chain. And also in particular, I'm talking about ingestion from clients to live streaming platforms. So what I think is nice in this diagram is it shows the variety of different clients we need to support. There are clients from the TV broadcast facilities where they use high-end hardware encoders, or it can be ingestion from consumer-level devices, game consoles, software such as OBS, or ingestion from browsers, mobile phones. So the diversity of this encoders ecosystem actually poses some unique challenges in terms of live ingestion. So first, I want to talk about some of the high-level requirements we see are needed in live ingestion protocols. So this is not necessarily an exhaustive list. It's just the requirements we consider that are important and where there are challenges. So first, we want to be able to support high visual quality live streams. For example, 4K HDR, but not limiting to that. We can see in the future there probably will be demand for even higher resolution and higher frame rate content. And this is mostly driven by broadcast level premium live events like sports, gaming tournaments, concerts. But we also see increasing demand from even general users, especially in terms of gaming live streams. So this leads to the next requirement about codec agility. In order to support high visual quality content, we want to use newer video codecs such as HEVC, VP9, even AV1 that can have better compression rate so that we can stream at high quality at a lower bit rate. And also some of the new features like HDR also requires new codec support. So it is very important for protocol to be able to update it easily whenever there's new codec coming out. And next requirement is about being able to support low and ultra low latency. And ultra low latency here, we mean less than 1 second. This is especially important for sports live streams and also game live streams where creators want to interact with viewers via chats. Here I want to highlight the need for the ability to do latency and quality trade-offs. I think basically everyone wants low latency, but you theoretically can always drive down latency by lowering quality, lowering the bit rate, resolution, or dropping frames. But this may not necessarily be like always the trade-off we want. For example, if it's a live concert, then maybe we can afford a little bit more latency in order to maintain high visual quality. The next requirement we see that's important is the ease of adoption among encoders for an ingestion protocol. As I show in the previous diagram, because there's a wide variety of encoders. So how to make sure all of them can adopt a certain protocol is important. And I think one of the keys for ease of adoption is ease of implementation. And lastly, we think it's important is the ease of large-scale employment, because we need to support many concurrent live streams at the same time. So being able to do load balancing correctly and easily is important. And also we need to do regular service update, and we want to do that without interrupting the live streams. So next, I want to talk about the challenges we see in some of the current live ingestion protocols in respect to the requirements I just talked about. So first of all, RTMP is one of the most commonly used live ingestion protocols. The main challenge we have with it is it doesn't have an official way to add new codecs. The protocol is not a little bit stagnant. It's not updated. The last update was like 2012. Furthermore, it uses a 4-bit enum for codec, so only 16 values for the codec. And you can see we will easily run out of values for new codecs. And also in terms of latency, because it is directly on top of TCP, so you can easily switch to use Quick for it. So it has the head of line blocking issue. So a few years ago, we also added support for using Webrtc to do live stream ingestion. We added primarily to be able to support live stream from browsers in order to lower the barrier for new creators. Our first-party mobile clients also use Webrtc for ingestion. The main challenge we have with Webrtc is its quality, because Webrtc is created for video conferencing. So it adapts the visual quality down very quickly in order to maintain conversational latency. We have a challenge with using it for premium content. So in order to support premium content and also to support new codecs in order to do HDR, we also added live stream. We also added support for ingestion using HRS and Dash. But these protocols also have its own issue where they have higher latency because they are segment-based. We understand that now there's newer version of it that support low latency. But we don't see a lot of demand like adoption from the encoders. And furthermore, because HRS and Dash, they're really created for delivery. So some of its constructs like the playlist and manifest, those are not really needed for ingestion, but we still need to support it. But they do add overhead in live streaming. Lastly, the Srt Protocol is a relatively new protocol. I think it's created mostly to solve some of the codec and latency issue. We do see that it has a very good adoption among TV broadcast providers. It is originally created for the point-to-point contribution use case. The challenge we see is when using it for large-scale deployment, because it is a UDP-based protocol, so load balancing is not a given for off-the-shelf load balancer for UDP, and also its current congestion control algorithm in a live mode may have some challenge for large-scale use. So to summarize, currently we don't see a perfect solution for ingesting high-end content at ultra-low latency and at large scale. We do see that Quick can provide a unique solution for some of the challenges like deployment and latency. So we're very happy to see that there are movements in this area. There are proposed Quick-based solutions, and some of them are specifically focusing on live media ingest. Some are like designed initially for delivery, but they can also be used for ingest. But in general, yeah, we're really looking forward to collaborate through the IETF community to find solutions that can address these challenges. That's all from me. Thanks.
Okay, Bernard?
Yes. So I'd like to talk a little bit about the trade-off between the latency and the quality. So when you implemented the Webrtc ingestion, natively you actually changed the congestion control algorithm to favor the quality over the latency. I'm wondering if the same problem exists with Quick, particularly the BBR congestion control in its probe RTT phase, and whether you foresee a need to change the congestion control algorithm to again favor the quality over the latency.
That is a good question. I think we really need some more experience with testing it, I think, like using the BBR and Quick. I can't give definite answer now, but yeah, no, that is a very good question. I think we need more testing with that.
Luke?
To answer Bernard's question a little bit, I've implemented BBR for Warp. And yeah, we see the issues with probe RTT state. I think it comes down to when you're doing frame-based delivery, you care way more about keeping queue sizes small. And that's just never really been a concern for TCP and therefore quick-based congestion control algorithms. So I definitely see that at least it's going to be algorithms that should be suited towards live video. And there's other issues like live video is mostly application limited. So a lot of the time you're not fully utilizing the congestion window and the algorithms aren't designed for that. So there's just a huge swath of space for optimizing congestion control for any quick solution we do.
Thanks. Spencer?
I wanted to thank Ying and Luke for bringing this presentation and the next presentations forward, and wanted to thank you both for answers to Bernard's question. I think that it's fair to say that the last time I asked about such things, the possibility, we just don't know that much in the congestion control ICCRG sense of the word. We just don't know that much about the interaction of various congestion control mechanisms that might be used from the same endpoint and how they would play with each other. The big issue for like Scream, the media control or media-oriented congestion control things was that they would not self-congest, self-congest, that they would not that they could share bandwidth between themselves and other connections that were doing Scream. And so the question about having two arbitrary congestion mechanisms, I think that that's still really early question, but I could be wrong.
Thanks. Harold?
Harold Lavestan. Just one thing I don't quite understand. You mentioned that Webrtc was problematic because it scaled down quality when congestion occurred. Now, in the live ingestion use case, you have a definite latency budget, right?
Yeah.
So that means that when you hit congestion, you have to either reduce quality or increase latency, right?
Right. Yeah,
So
but it's just the latency
that's kind
budget
of
is
fundamental to the information theory of the space. So the question is really whether you can get, if you have to drop latency, drop quality because latency otherwise will increase too much, whether you can get it back up fast enough, I think. And that is a common problem with every solution.
right. Yeah, yeah. I think that what I want to convey is the latency budget, though, is different for live stream versus video conferencing. But the Webrtc library, the commonly used library, is built for video conferencing, so it's really low.
There are control knobs on it.
Oh, then we would like to learn about that.
Before we go on to the next, I just close the queue currently, so let's see if we don't run out of time. And so let's see where we are when we have gone through this queue. Hang?
You are using SRT. due to do the live streaming ingest. I wonder what's wrong with the SRT. You mentioned it's difficult to do nice scale deployment.
Yeah, it's in terms of load balancing because of the UDP protocol itself, right? It's not connection based, so load balancing is definitely not a given. I'm not saying you can't do it; it's just more complicated. And
You
yeah,
also
and
need to do more things.
Sorry, Hung, I didn't hear if there was another part of your question or if you're done.
On UDP and its connection ID is end-to-end kind of encrypted. So you still need to do more things to do the load balancing on quick, right?
That's true. Yeah, I think the basically, I think for quick though, because it's connection based, and also load balancing is much well documented. I think that there are a lot of documentations on how to do load balancing for quick.
Thanks. Stefan?
So I have a few things. One is I want to support Harald in saying that I don't think we have a fundamental problem with the Webrtc protocol suite when it comes to the trade-off between latency and quality. I think we may have a problem with the current Webrtc implementations, right? We may not even have a problem with the implementations themselves, but a problem with the way how the implementations are configured. So there's indeed a lot of knobs that can be played with. So I think in that regard, the slides may be a little bit misleading because as Harald said, and I agree with that, the problem is a fundamental one, which should occur in the same way with all the other protocols, right? So that's point number one. Point number two is, I said that 1,000 times, I say it again, congestion control is overrated here in this organization. The networks nowadays are sufficiently elastic that, you know, you can push out more for a while without everything melting down. Certainly for a use case where you basically have only one stream, like ingestion, right? What happens in practice is people just ignore it and things work just fine. So, and that's something which would probably require a lot of, or at least some software work, both on the current Webrtc senders and also in the quick stack potentially. So my third thing is, and that's independent of this draft here, I think, and independent of the slide deck, I think it's time that we put together a draft that defines our view on the terminology for those various latencies, right? When I hear ultra low latency and I hear sub-seconds, yeah, something, my brain starts spinning. I come from the video coding field. Yeah, ultra high latency there is meant like single-digit milliseconds, right? Basically, you start shipping packets before you have encoded a whole frame. On the other hand, some of the TV guys think ultra low latency is when you don't send the whole GOP, so a group of pictures, right? So someone should write a draft. Maybe I write that myself one day. Yeah, and just put that terminology problem aside once and for good. Thank you.
I'll just jump in and say that with respect to that last point, that this draft that James and Spencer have written does have a classification of different things and tries to demarcate ultra low latencies lower than 1 second, because I think there's an agreement that 1 second is not really.
Then we need an ultra
Yeah,
low
no,
latency or a super low latency or, come on.
Yeah.
Or maybe the easiest way would be just forget about the terminology and just use categories like below a millisecond, up to 10 milliseconds, up to 100 milliseconds, up to 1 second, up to 5 seconds, and up to an hour.
Yeah, in fact, I think the draft calls it like ULL 250 and ULL 100 and things like that. So thanks, Simon. Cullen.
So I want to just come back to the congestion control issue because, you know, like it's IETF, there's nothing more important than congestion control. I don't want to give the impression that people have not played deeply with the congestion control in Quick. We understand, like, there's a ton of different people, including us, have done a lot of experiments with this, have played with it, have implemented alternative implementations. We've been working closely with Christian Huitois on the Pico Quick implementation, some of these types of things. What I would say, though, that's relevant for this BOF here is that I think there are things you could do to the Quick congestion controller that would improve it for media, no matter what type of media, what version of low latency you think you're dealing with, right? And we know some of those, and they seem like they could easily fit in with the Quick framework. I think that's something that's completely separate from this work, can be taken to the Quick working group of how to have something that's done for that. But what this working group, I think, needs to focus on is, given whatever you do get in Quick, which it is what it is today, and you get other things, is, you know, how do we build the type of rate adaptation, and how do we interact with that? Or, you know, how do we adapt what we're trying to accomplish as an application layer on top of what Quick basically gives us? And it's very clear that you can get a fair amount of, you can get a long ways on Quick as it stands today with no changes. And you could probably get slightly better if you made some changes to Quick, and those can be proposed separately over to the Quick working group. So that would be my view. But I don't think we're talking a lot about the congestion control issues and how we might want to change BBR and all of those issues here. But I do think that people have thought about that a lot and done a ton of experiments with it. That's it.
Thanks, Colin. Okay, Victor's got the last word.
Okay, can you hear me?
Yes.
Okay, so two things. The first thing is about congestion control quickly. As a person who spent a lot of time working on congestion control for live and non-live media delivery at YouTube, it does matter a lot to user experience and in non-trivial way. The second is more to comment about Webrtc. And I'm having a little bit of deja vu here because when web transport was first proposed, people assured me that things can be solved, web transport flows can be solved with Webrtc data channels. You just need to implement SDP and then implement ICE and things that run on top of it, and then implement SCTP, and then there are also dragons. And all of that is true because Webrtc is like network-wide Turing complete in the sense it can do anything, but that doesn't mean it is the best tool for the job. That is to say, if we went through, there are people who try to use it for delivering high-quality live media, and their experience was that it is not ready in the state it is, and the question would be, do we really want to turn Webrtc into something that can do this, or should we start building with a different starting point, like Quick? And I think, at least for me personally, Quick seems to be more promising because Quick dash over HTTP3 is a really mature, widely deployed solution.
Thank you, Ying and Luke. Let's go on with Luke.
Oh, hello. So I've got some non-professional slides just to mix it up. But yeah, I'm Luke. I work in Twitch for a while now, and Amazon. So I want to talk about distribution, mostly focusing on the requirements and use cases, and maybe going a little bit into the flame war that is this protocol can do X, Y, Z. Yeah, distribution. The the main difference with distribution is versus ingest is this fan out mechanism. It's no longer a one-to-one protocol. You have to make sure that whatever distribution protocol is designed to be replicated and passed off multiple hops. This includes passing off to CDNs. This includes just going around the world and fanning out to as many users as possible. So one broadcaster, multiple viewers. This has some ramifications. The big one is you just can't have feedback. You can't have the viewer send something to the encoder, say, hey, lower your bit rate. That just doesn't work because you have too many viewers trying to watch the same content. So it does limit the space a little bit. Your solutions, you can't, so that's why there's different protocols typically. The other thing that's, well, I kind of mentioned here is congestion. Because we can't tell the encoder, hey, lower your bit rate, we need to drop something. We need to somehow lower the bit rate. This is typically done using ABR. The idea is that you create different renditions and you can, at got boundaries, you can switch between them. It's very jerky, it's very slow and dramatic. You kind of have to plan in advance. So if I'm running into congestion right now, queues are building up, my buffer's depleting, and in 2 seconds I'll be able to like jump down 5 megabits per second all of a sudden. We don't really see frame dropping too much in distribution, but that's also an option. That would be another way to reduce the bit rate. And typically, instead, these protocols will buffer. HLS, you've seen it, like in Dash. If you've ever just your buffer runs out because this ABR wasn't fast enough for congestion control, you pause and you wait till the buffer fills up. The other thing is kind of unique for distribution is latency. So this, I imagine, will be talked about a lot. I don't like talking numbers. I think I see the chat people still arguing over like, is 25 or is 100 a right threshold? It really just depends on the broadcast, like what the and even the viewer, what the preference are. So if I'm doing a presentation like this, actually the latency doesn't matter that much. It could be, I call it interactive latency. Like people in chat can say stuff, but they don't need to be able to talk back to me. Obviously, if you're having a conversation, you want real time. You want it to be, you want to be able to talk to another person. But somebody is also watching from home, has no intention of interacting with chat, and they can watch it lossless. Maybe they don't want to drop any data at all. They want to see every pixel. Like they're watching a soccer game. So, like for the soccer example, you can have one viewer might care about they need real time. They need that their coach or something. They need to see the game ASAP. You could have another side where people are just maybe they're betting on the game, maybe they're chatting with their friends. They want lower latency there. They want to be interactive. And then the further spectrum, you have even the same people watching the same game, but they want to see all the action. They don't want to miss anything. So yes, the broadcast matters, but I think the big thing with distribution is the viewer matters, and the viewer's network especially. Somebody in the US on fiber can watch at a lower latency than somebody in Brazil on a cellular network. And the way that you can tweak the buffer size is very important for distribution, and hence the latency. And the other thing that doesn't get talked about too much is compatibility. So we have a lot of viewers, and we need to make sure it works on every device. In a broadcast scenario, you can get away a lot of the times with saying like, I have a studio, or I have a dedicated software I can run on the person's computer to create the stream. But for the distribution use case, we just don't have that luxury a lot of the time. Like it just needs to work on their TV, it needs to work in their browser, and it needs to work on their phone. And again, their network, it needs to work wherever they are in the world. You could be watching somebody streaming from the US, you could be watching from Korea, again, on a mobile device, on a desktop. And this has a lot of ramifications for the protocol. Of course, that's what we run into a lot. Honestly, the biggest thing with distribution, I think, is you're limited to only a handful of protocols based on compatibility more than anything else. So speaking of the protocols, so Twitch is an HLS stack. Specifically, we're using what we call LHLS. It's a chunk transfer variant that we developed. Also, if you want more details, I sent out a Google Doc about this before the talk to the mailing list. But the main issues with all the different flavors of HLS is it's got headline blocking. The idea is that all the data must arrive, like you must download every segment, and every segment depends on every previous segment, which means every frame depends on every previous frame, which means you need a large buffer to handle any variations in the network. There are obviously ways to reduce latency, like the fact that you have these different flavors of HLS, but you're still fundamentally limited by the fact that you just can't drop data. And if there is a network issue, you rely on ABR to switch to avoid it and to recover, and that's just too slow. We also have some issues with client-side ABR. That's just worth mentioning because when you deliver download frame by frame, it just breaks a lot of ABR algorithms that traditionally used for HLS. But it's not a it's something that there's a lot of different solutions, and we've done a lot of different things, including just like almost literally running a speed test while we're viewing the stream, just to try and figure out if we can switch up. So I was tasked with trying to reduce latency on Twitch, and we ran a big project to try and use Webrtc. Again, the document has more details, but this is a hybrid approach where we took our existing ingest stack and just tried to put Webrtc for distribution. The biggest issue with that was just we didn't have any control over the quality. We wanted to support these use cases where we don't need real time. In fact, we have like an ingest stack with a ton of latency, and then we try to use distribution at the very end, and Webrtc is forcing us to make it real time. We have to, a lot of people bringing up like, well, that's not a problem with the wire format. And that's true. Like Webrtc as a wire protocol, you can do a lot of stuff. There's a lot of extensions you can do. But again, for web support, we need the browser to work. And it's not a great way of conveying this information to. The implementation, because we need browser support, it means we have to petition Google to change things. We have to petition IETF to add stuff to the protocol. We wanted something that we had more control over. Again, using web transport, and the idea is that we could send packets, or we can do our own protocol. And you see this a lot, actually. You see a lot of people using Webrtc data channels to this extent. And we did too. I implemented basically RTP over Webrtc data channels. A crazy amount of complexity just to get UDP working in the browser. And it just wasn't a good experience. And yeah, I've implemented every Webrtc protocol at this point. I've optimized them. I ended up throwing away like a year and a half of work because we ended up abandoning this Webrtc Edge project. Again, this is some of our specific things. I think end-to-end Webrtc has fewer issues, but still quality is an issue. So our solution was to make something called Warp. I released a draft of it, a very simple draft, trying to focus more on the prioritization scheme. The idea is that we can have a latency gambit. We don't really do real time very well for a multitude of reasons, but it just works with our existing stack. It's CMAF, so we can fall back to HLS. There's server ABR, so we can fix some of the issues with our low latency HLS. And that's really what we're settling on. It uses web transport, and each segment is sent as a quick stream. It's actually really simple. But that's kind of what we settled on. And I don't want to spend my time like, preaching Warp. That's probably a future BOF or a future meeting. But any questions about distribution?
Mo, go ahead.
Mo Zanatti. Hey, look, I asked you this earlier on the list, and I think you mentioned that you had thought about it before, and you're going to still be, continue to think about it in the future. I wonder if you've had some more thoughts on it now. But it seems like conceptually Warp is would be very similar to having an H3 capable server and just grabbing the segments as separate resources over it, and they would automatically come over separate quick streams like Warp does. And then the prioritization, the mechanisms aren't there yet, but there's proposals to do something very similar to that prioritization. Do you think that there's more value in trying to pursue that route, or do you think that there's something that would be fundamentally harder to make the right changes that you think you're going to need eventually in an H3 stack versus what you're doing separately?
Fundamentally, we want to be able to download segments in parallel and prefer the newest data, like if there's congestion. And you can do that, like you mentioned, with H3. You can, I think Lucas was working on like a priority header. Would be a great standard way of saying this request should come before this one. The reason we're doing web transport really right now for distribution is just because Twitch we run our own CDN. Like we don't need to use HTTP. We're fine pushing last mile. But I think for standardization, especially, a solution that uses H3 or even H2 and looks more like Dash would probably be a low barrier to entry. There are some other concerns, mostly around server-side ABR, but it's all solvable.
Thanks, Lucas.
Hello, Lucas Pardew, Cloudflare. I hear my name mentioned and I'm summoned. No, thanks, Luke. Luke and I have talked a bit about this in the past. The HP extensible priorities draft entered Auth48 a couple of weeks ago, or a few weeks ago now, maybe. And this is just really about signaling and some guidance on how servers, predominantly servers in this case, can use those signals in ways to prioritize or schedule the sending of multiple resources that are concurrently active. That's just guidance. Effectively, servers can ignore it completely or do whatever they like. But it's optimized around the web use case. So it's kind of like a FIFO general recommendation that could be ignored. In speaking to Luke like months back, it seemed more like this use case is really like a LIFO. And that's completely possible. You might need a slightly different signal at the each independent priority message, or you might just want a signal for the entire session that this is a different kind of application than web. Like these things are possible. All I'd say is it is optimized around a client and a server model rather than a, maybe a video, which is slightly different.
Elaborate a little bit. One of the issues with using HTTP3 for Warp is if you talk to a server that doesn't support prioritization, like it just ignores that header, you're going to get a worse experience than just HLS. So like this is something that Lucas and I talked a lot about is you need to make sure the server supports prioritization if that was the approach we took.
Thanks, Suhas.
Hey, look, thanks for the presentation, and thanks for going us through various things that you tried out. And I had a clarification question. The more I kind of read about low latency dash and talking to the experts, it does feel like some of the things that you require kind of can be solved with low latency dash. Does Twitch or your team ever try to experiment with that and figure out something is not working and why it is not working, or is it something not done so far?
Our own low latency dash solution. It's a custom HLS thing instead of dash, but same concept as far as I can tell.
Okay. I think there's quite a bit difference in how the templatization and other things. But yeah, it would be good to know if that's explored at some point. Thanks.
Details, we advertise segments in the playlist, HLS playlist before they exist, and then the player will start downloading them with chunk transfer, and they'll be delivered frame by frame. So not the exact same as low latency dash, but pretty close.
Okay, Sergio?
Hi. One question from your presentation is that regarding it. Would you be interested in MediaAbr Quick or specifically about MediaAbr Web Transport? Because they are slightly similar, but I think that we need to first start thinking if the goal is to have MediaAbr Quick, or if we really are requiring web transport for the for the specifically for viewing in browsers, because I think that this has some extra challenges that are not only present if just using Quick.
Quick is mostly required to better eliminate head-of-line blocking, but there's actually some other benefits with web transport, like H2 fallback would probably actually work, thinking about it. It wouldn't be ideal. You'd still have some head-of-line blocking, but it would be nice. But really, we just need browser support, and like you can't get Quick native in the browser without web transport. So that's why we're focusing on it.
Okay,
I'm not sure.
Yeah, because we have the problem of specifically in web transport, how to block the congestion control of the quick implementation in the browsers with the user spec. So I think that speaking about MediaAbr Quick without specifically stating that this is going to be used with web transport, it may lead to some issues when we try to actually implement them.
To elaborate, we don't have that issue because the sender is a server we control. We have a custom Quick implementation. But 100%, if you're doing ingest over web transport via the browser, you do not control the prioritization of streams, and you do not control congestion control, and that would be an issue.
Yeah. So the queue is closed, but there are a couple of comments to be relayed from the chat. Kirill says that refreshing manifest for LL dash is not fun. And Lucas said needing per request signals to express priority introduces an immediate latency cost, whereas my understanding of Warp's needs is that a declaration that the session is best served LIFO will avoid that entirely. And with that, I think we're ready to move on to Colin's presentation.
Great, thank you. Can you guys hear me fine?
Yes.
Okay, so next slide, please.
You should have control at the bottom.
Oh, yeah, thanks. I'm going to talk a little bit more about the various sort of solutions that have been talked about and try and abstract those out to the type of thing that the direction that we could choose for a working group quick form to go. But to clarify that up, I want to talk a little bit more about a couple of use cases here. And I hadn't seen it into the MOPS-BOF the other day, this report from -IF, but it has a great set of use cases I highly recommend people reading. And of course, I think it's great. Several of the use cases I put beforehand were in there. But it is a good summary. I'd encourage people to read the links at the bottom there. So use case I want to talk about right here is one that often comes up of, you have a soccer game or some people, a sport like that, and you're watching, and there's a bunch of different things that people want to do that aren't really very easy to do with the protocols we have today. And that's one of the things that in general, when I'm looking at building some new complicated thing that's difficult to deploy, I want to make sure that I have some features that are not just better versions of what is already deployed today, but are actually solve problems that people want to solve that you can't do with the stuff that is widely deployed today. Otherwise, you end up with a very difficult deploy path. So the soccer game example, when we start looking at this, there's a desire to be able to watch a camera over the goal post when you're right in the same stadium watching the game. It's very common now for people to be streaming those types of things. There's the issue somebody brought up later of the sort of timing and latency of everybody receiving this, so that we have that the end viewers are getting a fairly low latency version of the game, so you don't hear all your neighbors cheer beforehand. Some people don't care about the problem, some do, right? And this one variant of this that gets particularly into that thing is when there's betting going on. For anything that has regulated betting on it is highly likely to have very strict latency needs, and you don't want somebody who's just sending a Webrtc video of the game from their phone to somebody else remotely to be getting a substantially lower delay than whatever the betting delay is. So that's another one that comes up. The other one that we sort of see is that you have a large number of people viewing it, well beyond where WebRTC is typically scaled to today. I mean, most of the large-scale WebRTC systems support single conferences up to around 1,000 people. Obviously, you could do more than that with WebRTC less, but it tends to be in that sort of framework is what's cost-effective. But if you have 100,000 people viewing this and you want to be able to bring in any one of them as a participant, as an interactive person on the call, maybe it's an esports and you want to bring in one of the fans or spectators as part of the commentary that's going on live in it. Now, the moment where you bring those people in is you don't want to lose 5 seconds of latency that person doesn't hear when that switch happens, because that's exactly the context they need to comment when they come in. So you have to keep, that means driving the latency of everything down. So I think there's a bunch of edge cases like this where we switch back and forth. Let me talk about a slightly different version of this. This is large company meetings. Right now, if you have a meeting even like this one, right, with only, I see we got 129 people remote right now. If we allowed all those people to just be active speakers at the same time, it wouldn't really work. That's why we request the queue and go do these things. So there's usually a signaling mechanism that allows people to move back and forth between an interactive and non-interactive mechanism. Now, we can usually do this with WebRTC today for small meetings, but it doesn't scale very well as it sort of gets large. So that's certainly a use case that's coming not from the streaming direction, but is coming from, I'll call it the interactive media direction. And what we see is more and more use cases where coming from both of these groups that are converging to the same thing, where they want to act a little bit more, the streaming people want to be a little bit more like the interactive people, and the interactive people want to scale like the ability of the streaming people. The design that we have for scaling for streaming today is amazing. The other thing that we sort of talk about a lot is the way that streaming uses relays and distribution points on the distribution is very clear. We're all familiar with those types of things. But there are also a lot of things that can be gained by similar models on the ingress. And what the main place where you have gains here is if you had a relay or a cache node, some type of thing that's on the other side of a network like a Wi-Fi. I mean, in many cases, we see the actual problems that you're hitting with the loss of packets, various congestion control issues and stuff happening very much at the Wi-Fi network or the very last edge. And if you can insert a relay there, you end up with a very low latency between the end client that's producing the video and this relay. And you can do retransmission based, you can run quick over a stream and get your data really quickly, reliably across that link and then put it up. So basically, we all understand the sort of issues of how RTT and congestion control relate with each other in retransmissions. But if you can reduce your RTT dramatically by inserting relays at key points, you can change this. And this really comes to some of the things that are changing in the network today. I mean, what's happening with 5G and the ability to have compute very near the edge, what's happening with very flexible access points to push stuff down in them, allows us to have an ingest side CDN effectively as well that dramatically improves quality. So a bunch of this is all changing. So with those sort of use cases in mind, I want to jump over to the looking at sort of the design solution space. And I'm not arguing for any of the particular drafts one way or another here or anything. I don't really care about that. I'm sort of pointing out like a bunch of different people have looked at this different ways, and we're all coming up with very similar things. Okay. We all have some way of publishing and pushing the media, and Overquick, that's why this is called Overquick. And they, they tend to put dependence video frames like a GOP sequence in one stream. They tend to have some way of trying to think about how to allow multiples of those happens, maybe how to prioritize them, those types of issues. The most important thing for us to focus on initially is a little bit what this pub line looks like, and whether it's Rush is just bringing on the ingress, Warp can do both directions on this. We need to have that video together. We need to think about how the congestion control relates to it. So I do not think that this work should, as I said earlier, I don't think this work should take on any of the congestion control. I think that should happen in Quick. Quick provides you what it provides you, and we can maybe improve that for media. But it's also needs to provide us like write estimates. because we need those, and we need to be able to adapt to them quickly, and we need to be discussing the strategies that we're using for the latency. I mean, Luke got me on this term of latency strategy, and I think that's a very good way of thinking about it. That's what we need to do. And this is one of the things too that comes up constantly is, well, couldn't the ingress and couldn't the what's coming in and what's going out be completely unrelated to each other? And the answer is basically no, they can't. They are highly related to each other. They don't have to be the same protocol. We've proved that, and obviously we'll gateway to different protocols. But whatever your strategy is for dealing with latency on one side, if your strategy for dealing with the latency on the other side is totally mismatched with that, you have problems. Every time somebody says, oh no, we don't, they can be completely separate, they inevitably have a set of assumptions and models about what the output is that they're trying to get their input to match up with. And those outputs could be different. And, Jake brought up some of those issues earlier on some of these things. So I do think that we have to deeply consider both sides of this together, and they have to be designed to work together to meet the goals that we want or won't happen. I've not heard any compelling reason at all why they can't actually be the same protocol for both how video and audio media moves, on the ingress side to the egress side. See if I want to make sure I'm not missing too many things I want to say about that slide. Okay, so jumping into a little bit more the other side of this here. The latency part of this is a little bit of a red herring in some ways. We talk about what constantly people are trying to figure out a definition for, what different latencies are. But the reality is that we can get a certain latency over quick, and we can do it pretty reliably today. The various implementations measure this and tested it. Our stuff is currently sitting on top of PicoQuick, and we're open sourcing all the implementations of it if people want to play with it. But I'm not arguing for that one. I'm just saying that everybody that working in this space has implemented enough things that we sort of figured out what we can do over quick. Now, we can get the sort of latencies that we expect for interactive WebRTC type things over quick over these types of protocols that all of these things are designing. Okay, so I don't think we should get too wrapped up on exactly what that is. I think that that to improve beyond that, you have to change quick or use something other than quick, and that's really out of scope. We should just be like, hey, we can get what latency we can over that and get those use cases. The other thing that I think that we sort of fuzz sometimes on this and don't talk about that we should take account into the design very much is the relay issue. So all the large-scale existing deployments of these very things, streaming or interactive, have these. I mean, the CDNs have CDN nodes of some type. They might be very much HTTP caches. They might be some sort of extended support to HTTP type cache that's designed specifically to work with HLS. They might be something completely, internally designed. Twitch may have designed something that works just for them, right? Or, those types of issues. On the interactive media, we call these, cascaded SFUs. And if you look at how conferences, like large-scale conferences that involve people across multiple geographies work, there's always multiple relays and distribution points and SFUs involved. Now, there's a tendency to say, well, let's just pretend those don't exist in our design. We won't think about them, and then we can insert them in later. And I don't think that that's working out very well for us. I think we need to explicitly consider the relays in the design because they really change it. They're one of the complicated parts of the cost points to change. They also, our current sort of, right now there's a lot of people figuring out how to, remove all their private keys from their TLS private keys from their CDNs in Russia before they're seized. Like just this faking the origin in a relay may not have been the best design model for it. So I think that we do need to think explicitly about how these work and what we need to do, and recognize that for this to be a successful deployment, they're one of the people that have to have an incentive for the relays to deploy and work. A lot of the stuff too of, that came up earlier about, well, WebRTC or not. I mean, I think we could put anything in a browser as long as there was an incentive for the browser to put it in there and it meant the safety and security constraints that the browsers promise to their users as part of it going on in. So I think changes are possible there too, including doing a whole new protocol I also think that everything that we've been talking about here, just trivially, you can map it on top of web transport or on quick, raw. You know, that's the type of thing that could be worked out very much in the working group much later. What we need to agree here is just sort of the overall scope of these things coming together. So with that, I want to just sort of end with where I think loosely we should be going and having this. And that is, I think we should have a sort of North Star of an eventual solution and architecture that solves a lot of the hard use cases that we want to be able to deal with. And that's really important to have the incentives to make all of this and the incentives to deploy it, those types of issues. Now, that said, I don't think we have to do all of that day one. I think day one, we can start on some of the use cases that are most important to people, which have really been over what were the pub arrows in all of these diagrams of how to push this stuff around. And, you know, I think that where we need to be there is we need options around figuring out how we prioritize those, how we put them in streams, how we put those in things. And we need to rely on the fact we're sitting on top of Quick's existing congestion control. I think that a lot of the current discussions we had today are pretty lacking on discussing a little bit about how audio fits into some of that, and probably some of the proposals, you know, that's how audio fits in there is going to require options for datagrams in some cases, or on streams. I think there'll be some things where you need to choose both of those. Content naming and how we do that, we sort of brushed off. I'm not saying we should do signaling, but I do think that you can't, if you want to build an interoperable device that connects up to somebody's Ingress streaming server or not, you have to understand, like, you know, people say, oh, it's just in the URI or something. Yeah, that's great, that's fine. But you have to say how that is. And you need to realize that how we express URIs and stuff is one of the major costs in some of the existing CDN deployments. And maybe that the incentives to CDNs are designing that a little bit more optimized for CDNs instead of forcing onto CDNs something that was not designed for them to start with, or whoever's doing the relay node type ideas. I definitely think that we need to design the ingest and the distribution to work together. I actually don't really see any reason that protocols would be different for pushing the video around, but maybe somebody can convince me. There's the question about WebRTC. I mean, my view is not that we couldn't do this on WebRTC. I mean, WebRTC is a beautiful cathedral, and we could definitely add some more gargoyles to the edge of it to do whatever we want. The problem is just the complexity, the size putting into clients, the getting new things out. So I think that is one of the biggest concerns in thinking about whether you should do this work or not is, well, can you just already do it some other way? And maybe the answer to that's yes. But my view is it's pretty complicated, and that really the RTP was not particularly well designed for large-scale distribution out in the relay content zone. And I know that RTP was designed for multicast. And really what I'm proposing here is an application level multicast. But I think RTP in its practical usage has moved a long ways away from being a multicast or an application layer multicast network over top of it. So I just think it's a very, very difficult thing to map over to what we need here, particularly on the distribution side. And with that, let me just go to questions.
Yeah, this is clarifying questions. We will soon go into the discussion part. So if you have any clarification questions to Colin, please go ahead. Spencer?
Spencer Dawkins. This may be a clarifying question or the beginning of discussion, but I turned my hand on to ask Luke about his comments on latency, and I appreciate Cullen putting up a slide about doing things with no relays, and for the reasons why he was, why you named that. But Luke's categories included a thing called international, and I don't have to have an answer here, but I think the question is worth us asking. What does that mean? Does that mean that it's a long way from our CDN? or that it's a long way over our CDN with and over a lossy network at that point, or something else. But like I said, your comment about doing things without relays, I think really speaks to that. And I think that's yes, Stefan is still here, so I can say the draft that he offered to write may be very useful for that as well. Thank you.
And I will say something about that. I mean, I think that it's very easy to design something that works well on good networks. And that comes back to Stefan or somebody said earlier, like, you can just ignore, you can just send stuff as fast as you want and just sort of ignore all normal things about networks. And it works a lot of the time. It really does. The problem is, it's the hard cases where it doesn't work. I mean, if you have a service that doesn't work in 5% of network connections, and look, just sending with no considerations whatsoever will fail more often than that, it's not going to be a viable service. I also think you need to be talking about is really a lot of countries. So I'm very deeply familiar with deployments that work in most of the countries in the world, and what it takes to provide a reasonable quality interactive media in all of those environments. To do that, and this is very common across all of these major services and even different things. You see people today using at least about 100 points of presence for their CDNs or SFUs or whatever to get the latency low enough to deliver the type of things they do today. And that's not just for web conferencing, that's across a wide range of things that are interactive. You end up about that many points. I think we're about to see a massive change in the general CDN networks where the number of points of presence that you have just goes wildly up. If you look at delivering something like Stadia or that sort of interactive gaming type thing, my belief on that is you need a lot more points of presence than that, and that we're going to get them. And so you're going to see people selecting a CDN, like which CDN they use, like in a very small area, be able to choose from different ones versus just, I got US West and that's close enough. I mean, I think it's going to be down to per city levels or even lower. So I think that that's one of the things that makes this type of protocol exciting now, is to be able to take advantage of a CDN market that's going to rapidly change over the next 7 years.
Right. So I've been thinking about this as a transport person.
Sit down. You're rambling. Come back and
I can so there are people in line behind me for clarifying questions. So I will step to the back of the line for them.
Yeah. So Julius.
Yes, so that's just a quick comment. When you're speaking about doing a group of pictures over one stream, I'm a little bit concerned about how it can generalize to SVC. So when you're doing SVC, you really want to avoid being blocked by a higher layer packet. You want to avoid suffering from head-of-line blocking. And I'm a little bit concerned that we might be painting ourselves into a corner here by making this choice.
You're 100% right. I totally believe in scalable codecs. I believed in them for way too long, and they keep not deploying. But I mean, I think, yeah. And I think like this is exactly the work the working group should do, is nail down, how does this really work? If you look at our actual proposals, both going back to RIPT and then coming into the quicker stuff, I mean, yeah, we want to have different, we want to be able to put different layers in different streams with different priorities to be able to deal with that type of stuff. So take that as a gross oversimplification, what I have on that slide. You're 100% right.
Cool. Okay, Luke, quickly.
I wanted to answer Spencer a little bit and add maybe a little new requirement. Sometimes relays are expensive. Sometimes, like we have for Twitch, we have a lot of broadcasts that have 0-1 viewers. We don't want to pay to send the data over a backbone and over these relays. So one of our requirements is that, yes, literally they can download a stream like over the Atlantic, right? Like RTT is huge. There's a lot of congestion because they're using transit, but that's way cheaper for us. Pros and cons.
Thanks. Sanjay, quickly.
Hi, Colin. This is Sanjay Mishra, Verizon. Very good presentation, and I think obviously it's very exciting to see some of the conversation here. But looking operationally, folks that are actually implementing real-time distribution with WebRTC today, and doing a lot of investment in that. So what would be really for them to sort of turn around and say that, this really offers me something better and I need to redo my distribution. So what's in there? Is it the congestion control that's going to be the thing that would cause them to move, or what's the consideration here for folks that are doing investment now in WebRTC to consider and move? Thanks.
So like I work on WebEx, which has a huge investment on WebRTC and being able to use that to bring everyone in. It's been amazing and good. But the thing that really moves us is dramatically lowering the cost of scaling out the distribution while still keeping the latencies we want. It would be, the thing that would really drive us to move to this. I think there's other people that are very much coming more from the streaming direction where they have, a great distribution protocol right now, and they're struggling to have a good ingress protocol. And some of them are finding WebRTC too complicated, or some of them are finding the other options that they have as an ingress protocol are not really driving the real-time latencies they want, and being able to switch back and forth to some of these use cases. But I think you are hitting on the heart of the problem here, which is, do we have something that is enough different and enough interesting that it will really take off over WebRTC, or over just using WebRTC to do a similar thing? And that's a hard question to answer without digging into a fair amount of the work.
Okay, so thanks, Colin. And we're going to move into the sort of general discussion. We've got about 25 minutes for general discussion. Just want to acknowledge there's a lot of people here. There's a lot of different backgrounds and use cases that are important. So everyone just, and some people are very passionate about their favorite protocol and whether it scales. So try to keep it civil and, try to bring, new information that's going to help drive the work forward. And please be brief and try to avoid rat holes and bike heads. Thanks.
Now, welcome to Queue Up.
Spencer.
That guy. I'm Spencer Dawkins, and just to follow up on my second thing with Cullen was that the IAB has spent a certain amount of time thinking about centralization, and so the decisions we make about operating without relays and what the requirements really are and things like that may have pretty profound implications for how centralized the internet becomes, either more or less. Thank you.
Thanks. Bernard?
Yeah, what I've heard is, and I've heard this in other places as well, is that there is a real interest in getting a new ingestion protocol for the reasons that Ying described. So I think there's definitely something that needs to be done there. But one of the things I've noticed in reading the requirements for different ingestion protocols is they are subtly different. So I'm just wondering if for example, something like RIST seems to have slightly different requirements than what we're talking about here. So I'm wondering if we can bring some of those folks in so we get a very clear problem statement there. Thanks.
Thank you. Tom?
Hi there, Tom Hill, BT. I was actually quite interested to see the hierarchical unicast delivery subpub mechanism in the architecture draft for QuickR. Has there been any discussion? I can't see any at present, but has there been any discussion on a multicast delivery model as part of this, or is there any part of the architecture that precludes that from being possible in the future?
Colin, did you want to jump in and answer that real quick?
I do. Yes, and that there has been a bunch of discussion about it. I don't think it really has resolved, and it comes down to an argument about how deployable multicast is. And people always say multicast is not possible to deploy while selecting their printer with MDNS and watching their video for video on demand over a multi-class service run by cable companies. So I think that there is. So the way I have described Quicker is there's many ways to think of it. It is both a named data networking type protocol, but it's also an application layer multicast, and it's also pub sub bus. I think that if you had the quicker or a model like that working as an application layer multicast, if you were in a constrained environment that actually supported real multicast, you could go to one of these relays and the relays could reflect the data into true proper multicast inside of that environment, and then pull it out. One of the reasons that I haven't been pushing building that as much is multicast on Wi-Fi net. Like the more we move to wireless and what multicast means on a Wi-Fi network or a cellular network is a pretty bad story. So I think it all gets complicated, but it's one of the things that I really like about this architecture is it opens the door to having some of the segments use real multicast.
Thanks. Stefan?
So the Stefan Wenger. So the question here was, where should we focus on? And my personal preference is to focus on a way in the distribution side of the story to go away from the 3 seconds or so latency that we have at the moment when we switch channels on a TV, right? That's just so ridiculous. If we could do something there, that's where the money is. On the ingest side, I know we are not in the good old times when the TV trucks were driving around and satellite links were used and so on, but it's still really small. And I also question a little bit whether real standard solutions are required there. I think the world has survived so far quite well on a handful of, let's call them industry standards, and call them standards because it sounds good, yeah, but in fact, it's basically documentable implementations, right? And that was good enough, and I don't see a reason why an organization as big and cumbersome as us needs to get seriously involved there. So I would go for the distribution. That's where the money is. Thank you.
Thanks. Stuart?
Just a quick comment. I've been sitting here wondering whether to say anything, and I think I will. Someone made a comment earlier that congestion control is overrated. And I've heard this from other people. So I just want to describe that the engineers that have said this to me are the same engineers that write their own protocol that runs over UDP. And separately, they report, yeah, sometimes it works, and sometimes it doesn't. Sometimes it just spectacularly fails and doesn't work at all, and nobody knows why. The network's just not good enough. And they do not see the connection between these two statements. So I am very optimistic about media and other things running over quick. For people who, for whatever reason, feel like TCP doesn't meet their needs, Quick has much richer semantics with multiple streams and priorities, but it has a competent congestion control algorithm underlying it all. So that's why I'm very optimistic that many of these homegrown protocols running on top of a competent congestion controller will be better than running over raw UDP, and sometimes they just don't work and nobody knows why.
Thanks. Pete?
Stuart's tall. Pete Resnick. So I've been sitting here still trying to figure out what this intrinsically has to do with Quick. It sounds like there's new protocol to be written at upper layers. I know it's quaint to talk about layers anymore, but and it sounds like Quick has some stuff underneath it that will help those protocols work better. But beyond an applicability statement that says, this is why you should use Quick underneath because these things in this higher layer protocol are going to work better or work at all. This doesn't seem like a Quick thing. This seems like media protocol stuff.
Yeah. Exactly.
I may just jump in and express a personal opinion, which is that Quick brings a lot to the table, sort of off the shelf, that can be reused, and that it can lead to simplicity at higher layers. That may come at a cost as well, But I think that is, sort of, as one of the people who got like us talking about media over quick, I think that's one of the drivers for why quick is built into the name of this.
Right, and I don't want to dismiss that at all. It's just, I don't think that this working group should limit itself in the sense that if someone comes up with the cool way to use SCTP to do that and is deployable, I don't know how that works, but okay, God bless them, they can go ahead and do that, but that this working group shouldn't be thinking necessarily in terms of quick, but in terms of the underlying structure that it needs.
Yeah, thank you. Suhas.
Hi, a couple of points. Just responding to Pete is that I totally agree. So when we proposed Quicker, one of the things that was called was Media Delivery Protocol, and the initial thinking was around UDP. There was no Quick as such, but that goes to the point, saying that it's a Media Delivery Protocol that this working group should solve. And yes, if Quick can provide the benefits, we should definitely use, and the future versions of Quick provides additional benefits that gets looped into the delivery protocol. And also, I feel that it would be worth for the group's time to see what problems and use cases that we bring in that today's solutions do not solve, or today's solutions do not scale out, or in whatever problems that we see. Like, say, it's a simple question about why something like low latency dash cannot work on the distribution side. And at the same time, some other things I would also like to know about is how does the end-to-end security come into the picture? Would that mean something like today's solutions, it would be hard to get something like that working or not? And also, one of the things I'm very curious or interested to solve is that how do we avoid multiple encapsulation, decapsulation of the media that's going from the ingest to the distribution, from to all the viewers, and not having to have multiple layers of encapsulation, decapsulation, and have efficient pipelining across these intermediate nodes. That way, we can achieve really good quality and latency combinations as well. Thanks.
Thank you. I remind you about being brief. James.
My response to Stefan earlier around focusing on distribution and not focusing on ingest is that there's two things that should be considered. The first one is that ingest protocols are becoming very diverse and very spread out, covering a whole bunch of different use cases, and maybe coming up with something that can harmonize some of those problems down would be very, very useful. It would certainly be useful in my domain, satellite trucks permitting. And the second thing to consider as well is that a lot of distribution protocols end up getting reused as ingest protocols. HLS, Dash, and RTMP all end up getting reused as some means of contributing into a distribution platform, right? And there's many CDNs and other services that have got that as a thing. And you've got to ask yourself, well, why are they doing that? And the answer is that if your input protocol and your output protocol are the same, then it's easier to reason with the architecture of the overall system and how things function as well. So if we don't focus on the ingest up front, then we certainly run the risk of it being bodged in the future.
Thanks. Victor?
I want to comment on the question of why Quick specifically and not other protocol. So at least with Google, we have at least 3 different teams that are dedicated to running, maintaining a transport stack. There is a Quick team, there is also the team that does work on improving TCP congestion control and other aspects in Linux kernel, and there is also a team that works on RTP, and there are some other protocols like SCTP we also use in some cases. And supporting those is not free. It takes a lot of effort. It takes a lot of very specialist knowledge, and a lot of investment in specific types of code like CPU optimization. And we spend a lot of time optimizing Quick for CPU because delivering video is is at scales that YouTube does just takes up a lot of resources. In that sense, being able to build upon all of this effort rather than building something new from scratch is a very important plus. And Dash over HTTP3 at this point is an extremely mature technology. And the reason I believe we should do this is not only from standpoint that this is a good idea, but this is also something that many people in the industry independently have built. Facebook built Rush, Twitch built Warp, and they work on this on fundamentally the same principles as they use quick avoidance of head-of-line blocking to push media. And I believe this means that this is the right direction because multiple people independently came up with this solution, and it is worth standardizing it.
So, thank you, Victor. Please be brief. We are closing the queue very soon.
Ted Hardy speaking. And I came up to kind of pick up on something that Magnus said in the chat a good while back, which is that fundamentally what this really is a discussion about whether it's time for a new media delivery protocol. And the point he made in chat was that Quick coming to the fore has kind of created a straw that broke the camel's back, or I would say that broke open the dam of discussion about whether or not it's time for a new media delivery protocol. And I think most of the people I've heard at both in the mic line and on the chat have basically said, yes, it's time for a new media delivery protocol. And the question is, why is it that Quick broke the dam and Webrtc did not? And I think the interesting thing about that is actually to go back to the point about multicast models. Multicast models are fundamentally a publication and subscribe. Somebody publishes a stream and you subscribe to it. And those publication subscribe models, especially with the kind of fan out that typically occurred in application layer multicast, are much easier with Quick because of the infrastructure that's been built up in the internet. So it's simply the case that CDN infrastructure and the rest of the infrastructure is friendlier to Quick because it shares H3 as one of its use cases than it would be to building something new on top of Webrtc. So I think the question we really have in front of us is, do we want a new media distribution protocol? And I think my answer is yes. Do we want it to be based on something where the fan-out possibilities of publication subscribe have this scaling property of Quick? And I think my answer to that is yes. And then I think we have kind of the question of, if we're going to do multicast and unicast for this, how many of these use cases are actually in scope? And I think my answer to that is, again, yes. If we're building a new media distribution protocol, it should actually cover all of the use cases that have been described, because then we get the best network effect of building on that infrastructure and building on the code bases that are there. So people have said we named this wrong. Sorry, bike shedding the name of something is one of our favorite occupations at the IETF. If you want to call it new media delivery protocol, yes or no, BOF, I think at the end of the day, chairs, your question will be very quick, because I think you'll get a resounding yes to its time.
Thanks, Mo.
Mo Zanetti, I'd like to briefly touch on three main themes that I'm hearing from a lot of people. So one on Quick versus non-Quick, two on ingest versus distribution, and three on latency trade-offs. So on Quick versus non-Quick, I think all the discussion about Webrtc and God forbid SCTP directly or SRT or other things, I think a lot of people have already done a lot of soul searching, and we arrived at Quick for a reason. It wasn't that we ignored, a lot of us have deployed, at as higher scale as possible, all those other solutions. And we've arrived at Quick for very good reasons. So I don't think we need to rehash all of that. And for the ingest for the contribution versus distribution, I don't think that there is really that much difference when you look at the all of the different needs at the lower layers and even at the app layer between those two cases. There's a few nuances. Contribution, may have more nuances about both live and pseudo live that I want to get this stream up reliably anyway, but give me the live edge as fast as you can, but also make sure that I can give full, contribution at a delayed time. That's the only nuance for contribution and distribution. The scale is obviously a difference. But when you look at the lower layers of the protocol required to deliver those things, there's really not that much difference. And the latency trade-offs, I keep hearing the trade-off between latency and quality. I think those are, false trade-offs. I think Harold put it well, but I think it was kind of lost in the room. The channel is your limit. The channel governs your quality. You can't get better quality by adding latency. If you're talking about a short-lived, 5-second ad, maybe, but not these long-lived flows that we're talking about. We're talking about distributing events. We're talking about live streaming, many minutes or hours worth of content. You can't get better quality than the channel by just increasing your latency. So that's a false dichotomy. What latency impacts is resilience. How resilient is your delivery of that? And so we need to take latency as a trade-off between resilience, not as a trade-off between quality. And the same applies for contribution and distribution. Ultra-low latency can be achieved with the best quality that the channel can provide in both of those cases.
Thanks. I'll just say we've got 5 people in the queue and 5 minutes left before we're going to end the discussion. So 60 seconds, David, go.
All right, I'll speak really quickly. David Skenazy, quick enthusiast. First off, I'm not going to beat over the dead horse of let's do this over quick. Of course, quick is awesome. Let's do this over quick. People have said why, and that's good. Second, speaking as an internet architecture enthusiast, I'd like to offer perhaps a suggestion to the proponents of this BOF. We've seen that, not going into the BOF questions because this is not working forming, but clearly there's interest, and it sounds like it makes sense for this to happen in IETF, and there's people who want to do the work. That's all great. What I worry about is we keep hearing all these use cases, which are awesome. I would love to see a list. My concern is I'm not entirely sure if we can agree on a list of requirements. So what I would recommend for the proponents is to have side meetings and refine this list. And if you can agree on on a list there, that's something that we can then have a working group forming BOF. Because if we agree on a set of requirements, that means we can tightly scope this for a working group and then start building a solution that meets those requirements. Right now, I'm not enough of an expert in this space to be able to tell if all those use cases have a single set of requirements, and that worries me a little bit. So that's what I would love to see. Thank you.
Thanks. Colin.
I just want to speak to the ingress issues, and there's a comment made earlier about hey, it's the distribution that's really where the money is, or whatever. I mean, yeah, there's obviously that's a larger scale side of it, but ingress is where we're failing the worst right now. I mean, if somebody are using non-proprietary setup for their system applications, probably the most common ingress is RTMP, and I mean that's really old. It's had a blind blocking over TCP, has all kinds of issues people have mentioned, and it's not like you can build a device that will work with anybody's ingress. I mean, when we do RTMP ingress to Facebook versus YouTube, we have to do it differently, and you have to understand all of that with those things. So I really think that we can't just pretend like ingress is currently solved right now. I think it's an area where the state of the art is like hair on fire, and that needs to be part of what we're looking at. Thanks.
All right, thanks, Colin. Justin?
Why quick question. I think everyone here is very excited about the fact that we're now going to have a protocol that's extremely widely deployed, both across clients as well as in public cloud architectures, and that protocol is capable of doing unreliable delivery. And so I think we're all looking and saying, well, what can we do with this? And it's interesting to see both Rush and Warp as ways of leveraging that sort of unreliable delivery feature within Quick to do things, solve problems that are being faced in the streaming world. I think we're also interested in trying to use it for other types of use cases, like some of these 50 millisecond, 200 millisecond latency problems. But we haven't yet seen a solution put forth that basically speaks to here's a need, and here's how Quick solves that. And I think we're all kind of really excited, as I said, because of the quick deployment. We know there'll be all these things we can do, but I think that we maybe wanted to focus on these concrete things that sort of apply to live streaming rather than some of the sort of future possible gains of making WebRTC easier to deploy, just because we have these concrete things in front of us. And hopefully, as time goes forward, we'll also see ways of how Quick makes WebRTC easier to deploy.
It's Max. Yes, Maxime, but this is the questions we'll at least do some polls on after we have gone through the queue.
Hi, this is Maxim Sharabayko, High Vision, SRT developer. So if anyone wants to talk about it, you're welcome. So I just wanted to add on our use case. We are currently one of the most popular protocols for live video contribution and distribution, and mainly for enterprise. And I just wanted to tell that the topic of congestion control is very important. But I would propose not to in terms of media over quick and protocol we develop here, not to take all the responsibility for congestion control and for latency, because when we talk about enterprise contributor, he really has some idea of what he's doing. He has some idea of the network, he has some idea of the quality. And if it wants to contribute really high quality of its video, but the transport layer limits it and drops this kind of stuff, it might be a temporal congestion, right? But you're dropping the quality like 4 or 5 seconds, and it's really a major thing that should not happen. And instead, if you could sustain this temporal congestion for some time, it would be better. And that's what we see. That's one of the reasons why SRT is currently so popular and important among enterprise contributors, is that we trust them more, we let them decide what to do. Thank you.
Thanks. And Harold.
Fantastic. I got the last word. So we have to learn from our experience with doing real-time media over the internet over the last few years, which is, after all, the basis of all the stuff we're doing here now, because that's media. Congestion control needs to open up so that application protocols can do more intelligent things than just throw packets away or queue them for later delivery. So designing the interface between congestion control and media is right at the core of what the IETF should be attacking. We have groups that know congestion control very well. We have groups that know media at least somewhat well. And making sure we draw on the experience of the last few years of low, for whatever value of low, latency, streaming of media, in designing that interface to congestion control. I think that's a core deliverable for whatever comes out of this effort.
Thanks.
Yes. So thank you everyone who's been very civil and have nicely contributed to the discussions here. I think we start with these 3 questions to see a bit of use the hand raising tool, show hands tool to figure out. So even those in the room, you need to use your VTech or Light or Full to give you input. I will start the first question now. So, and this is really just to figure out, give some indications, I think, to verify what the discussion has shown, that the interest, etc. But
sorry, just quick clarification.
Yes.
Raise hand means yes, do not raise hand means no.
Raise hand means yeah, yes.
Thanks.
Yes. Still ticking up here. I will give it a few more seconds. Yeah, I will end this now. Seems to be quite significant. 55 that raised their hand saying yes, there's something needs to be that's not met. They don't see. I mean,
I have a clarifying question about that. I realized I didn't understand the question. I didn't. Is this conversation we're having right now between you and I live?
Yes. People are saying yes.
Yes, Colin?
Yeah, I mean, okay, so I think the thing is that I just want to make sure that later in the minutes we don't redefine live to mean something completely discussed than what was in the BOF, right? That it includes things like what we're doing right now in Meet Echo. And then I think that, so I just want to have that point in there, okay?
Go ahead, Pete, but quickly.
I'll repeat what I yelled from the floor, which was simply, what do those 13 people mean who said no?
Do we have time to let someone speak, or should we, or no?
I mean, if those have input, it would be good if they could post why they don't believe, etc., or where. I mean, I interpret as my personal interpretation of that. Those 13 is saying they don't see there's a need to do something. There's no use case they see that can't be met. That's my interpretation. So let's go on to the media ingestion side here, or contribution, what do we call it? So, and yeah, raising hand if you believe there's not there's use case that's not met. So. Okay, I will soon end the poll, but it's still ticking up. Okay, I'm ending it now, or?
Sorry, can you, for all the polls, put the results in the chat because they're no longer accessible, just so we have them. Sorry.
Yeah. Okay. Thank you. I'm ending this. So there's.
You saw the comments in the chat. Some people feel like the third question is not real form.
Okay. Well, let's discuss the third question before. But just to summarize here, it's slightly less number of responses, but there are even more for that. That's with Ingest. It's not. There's not their use case that's not met today with today's protocols. So, Ted.
Ted Hardy speaking. As a couple other people in the chat, I think 3 might be a little bit confusing, and I'm suggesting a friendly amendment should work on these 2 use cases be done together as a friendly amendment.
Editing here. I'm trying to get it. Should work on these 2 use cases be done together? Was that what you said, Ted? As a reasonable
Sets of use cases.
2 sets. Okay. I will start the poll now. And raise hand is yes. Well, not participating shows a lower count, which means that, yeah. Okay, I think I'll very soon close it. So get your polls in. Thank you. And this had 58 participants, 50 saying yes and 8 saying no. I think it gives a fairly good indication of that some joint work and their interest, a significant interest in both of these two sets of use cases. So I think the next steps really is what I lined out here, saying, okay, can we scope this? And that the proponents, etc., will start looking into, okay, discussing on the mock list, seeing what we can do, working towards maybe charter or suitable place, but yeah. So, Murray, do you have any comments as AD for this both?
No, I don't think so. I think you've got the next steps that I would expect now. So, I'm good with what we have here.
Okay, well, that's we're just at time now. I really want to thank everybody for coming, for participating. I thought it was a really helpful session. It was good to see so many people here. I want to, of course, thank the ADs, thank the presenters, thank my co-chair, and everyone have a great rest of your week here. Poor Marie was, I think, pretty tired today. He just said, like, back to bed and then immediately closed his browser. Hi, it's nice to meet you in person. In the time of Corona, make sure we sanitize. It's going okay. Thank you guys for coming. For participating. Really appreciate it. All right. Great. Nice to meet you too in person. Thank you. Yeah. Yes, well, I think hopefully this will generate some discussion on the list, which has been a little bit sparse. And then, I would like to see us start to put together a charter. And if we can agree on and let people argue about what a charter should be, what it should be like on the list. If it goes well, then we can